네, 약속한 시간.
So it's time. Let us begin session 2. The second session garners a lot of attention since this session addresses AI. The topic of the session is AI in ports, autonomous and automation. Then, without further ado, let me invite our speakers and moderator onto the stage. Dr. Adolf K.Y, a professor of BNU, HKBU United International College, Dr. Hans Burmeister of Fraunhofer, and Mr. Do-hyeong Lim of Abacus, and last but not the least, Ms. Seouri Koo Sung, the Senior Terminal Process Manager of LBCT. Please welcome them with a big hand.
So, now I will turn the microphone to you. So can you get started?
Okay, so thank you very much, and good afternoon, everyone. And so welcome to the second session. And my name is Adolf K.Y, and I am a Dean and Chair Professor of the Beijing Normal University, Hong Kong Baptist University, United International College, and I will be chairing this session. And so I think before the start of this session, I think we agreed already, right? I think some of the housekeeping is each of us, we have a presentation of like not more than 15 minutes. And so after that, we should have around like 10 to 15 minutes that we can do some discussions and some Q&A. And so I think I'm the one who is the first to present. And I think this gives a little bit of pressure to myself, because then it means now I should not break my rules and present more than 15 minutes. But anyway, so I think this is what I will start. Oh, okay. Oh, okay. Okay, so I think first, so today what I would like to share with all of you. Oh, okay. So today, what we'd like to share with you is this topic: PortEdge, AI-driven sustainable workload coordination for smart port operation. So in this session, I was invited to give a presentation related to AI and innovation. And so my background myself is on port economics and management, and I've been thinking about what would be the relevant topic to share. And but I think very recently, my research team and myself, we were actually working on a project that are actually on the so-called edge computing and the application of edge computing and AI on not only on port, but also port and also supply chain resilience. And so I think that's why I think that could be a very good topic that can be shared today with all of you. And so a disclaimer that, of course, first, this is still an ongoing project. And also at the same time, too, this is far from just me working on the project. In fact, they are both including my research fellows and also my PhD students. They are also working very hard on this project. And so also full credit to them. So let's say, in case that you are not aware of what is so-called edge computing, I will just very, very briefly explain what is edge computing. Put it simple, edge computing is the way to put data to nearer to the device, so instead of keeping the data only in the central storage unit. So that has actually a few advantages, because especially nowadays we have a lot of things that will actually need a much more efficient, much quicker responses. So for example, a good example would be like automated vehicles that any type of responses should actually be fast enough to avoid, for example, to avoid an accident or to have a very quick reaction. And so that is what it is on a very simple term about what is edge computing. And so I think in this case, when we are talking about the case of ports and supply chain, this could be something that could be very, very interesting, because I think nowadays, as we have seen in the morning sessions, there have been discussion that in the shipping and the maritime industry, there has been a lot of changing, a lot of changes, a lot of evolution, transformation in terms of, for example, shipping alliances and then circular ports, etc. So one thing that we need, especially to enhance resilience of port and supply chain, is actually about improving its responses. And also on the other hand, one of the disadvantages about edge computing is that the data comes nearer to the device, so you have a quicker response. But I think as you can see from this diagram, you can actually see that is a very so-called N-edge cloud network, that you have the cloud, which is the global data set, of which the data is shared with the layers, with the edge in the middle, and finally so the edge will actually have the interactions with the devices. It's not really a learning process. It's something that data, it will come up with a certain type of reaction of which it will be more efficient. But however, if we can see that shipping alliances could change, network could change, the supply chain could change, the coordination, the relationship would change, we recognize that there seems to be that there's a need for a process of which the system have to be able to learn, and they have to learn quickly. And so, in our opinion, that is what we believe that AI will be able to play a very important role in actually improving the so-called the edge computing system, so that in terms of port operation, it will have a much bigger, faster response, much more efficient response, and also a much more enhancing the resilience of the port. So I think what we are saying, probably I will just skip the word because of time limitation, but I think what is important, what we can see here, is that we are transforming the system into a kind of a triangular relationship, of which on the top we still have the cloud, which is this global data set, but then on the right-hand side, what we have is the so-called is the edge, and you can see that in the edge, instead of just about workload coordination, of which how the cloud is coordinating the work with the edge, there is also a feedback which is called AI model sharing, of which the use of AI, how the experience of the edge that they experience from the changing circumstances will provide the type of lessons back to the cloud, and how the AI will actually help the cloud to learn, and in turn that will actually enhance the edge to allocate work to different devices. And on the other hand too, the devices is also directly connected to the cloud in a way of which that will involve a lot of the so-called application requests, feedback retrieval, and while the devices will also have local feature exchange, and also what is also important with the edge is ubiquitous edge intelligence, or what we so-called the UEI, that will be able to enhance the interaction and also helping the devices to learn and make different decisions under different circumstances. And so, but one thing in here which is very important when we are talking about the so-called the function assignment, because you can see that, and I think all of you will understand, no matter we are talking about a port coordination, or even about the supply chain in general, there will be a lot of tasks of which there will involve a lot of decision making, or to put it this way, a lot of the so-called the neurons, or the so-called neural networks. And so I think in terms of the edging, what is important is that all these type of neurons, as you can see by the different circles with different colors, they have to be allocated to different edges, of which different layers of edges, they will allocate different type of neurons and into a different device. And I think in here, when we are considering about the efficiency or how edge computing could enhance port resilience and port efficiency, that is something which is very important, is what exactly are the neurons to be allocated to each edge, and how each edge would allocate the neurons to each device, because each of them will actually affect the communication of the system. And also in turn that it will also affect the efficiency as well as the so-called energy cost of the system in carrying out its duties. So I think you can see that there are actually a bunch of equations. I'm not going to get into those equations, but put it very simple. If we go back to the slide, two of the very important points is that the system itself, what we want to do, as highlighted in yellow, we want to minimize the job completion time and also to reduce the runtime energy cost. These are the two things. And that is what we are developing in our research team is the so-called, we introduced the so-called the PortEdge. And to use the PortEdge to try to optimize job completion time and also minimize the runtime energy cost so as to enhance the whole, the system, the running of the port, especially the port that is under a changing transformation and facing different circumstances. So what is job completion time, how to define it, and what is the runtime energy cost? So for job completion time, put it very simple. We try to put it into number one is the so-called the function completion time, of which the time, how this particular function, this particular order could be completed. And so it's actually, if you can see here, I think in the equation it actually means that we define function as an equation that is related to first about the computational capacity, the bandwidth, as well as also the frequency of a computational cycle. And so it's really about how the system complete its function. But at the same time, as you can see from different layers, we also have the communication time, of which the communication time is related to actually is the capacity and the bandwidth, as well as the type of devices that are being used. So combining the so-called the function completion time and also the communication time, that's what we could see is the so-called the job completion time. But of course, on the other hand, when we talk about job completion time, that's always involve a cost. In the computer system, what mainly will be involved into the so-called the energy, the runtime energy cost will be two things. Number one is the so-called computational energy cost. Or put it simple, or using a much easier way to understand it is like your electric bills, right? How much energy do you actually pay for it? But in computer system, we also have another thing which is called so-called the heat dissipation. I think this is something that I believe all of us would have experienced, that when we are using say an iPhone, sometimes we found that the phone suddenly become very hot, really hot, right? And so we say, okay, let's switch off the phone, or we just try to let it rest for a while. In the computer system, why it's getting hot? It's simply because of the fact that it is actually running the data, of which in this process is actually accumulate a lot of energy, which actually raise the temperature and actually make it hot. So when we are talking about running the system, there is also a cost about how to dissipate the heat. And so these two things, when they combine together, that we need also to try to minimize the cost. We also want to minimize the cost for heat dissipation. And all these, we come up with the so-called runtime energy cost. And so put it very simple, in this system, what it needs to do is, number one, of course, to maximize the job completion, efficiency, and also to minimize the cost. But at the same time, the function of AI in here is that it's a learning process of which that it will continue to learn. It will continue to learn and to actually to continue to optimize itself so that it will always try to strive to enhance the efficiency and lower the cost. And so I think I will skip here. But I think put it very simple. If you actually look at this diagram, that is exactly the relationship between the device and the cloud, of which is about the relationship on how the device could contribute to the cost and also the job completion time, while the cloud can also provide the so-called model partition and function assignment, and which it will come up as a continuous learning process. How many cycles of iteration would actually end up allowing the system to learn, to actually say learn and evolve? That will be something that is, I think, from our perspective too. We are also, in the team, we are also developing and working on the system and see how we can actually, say, reduce the number of cycles in completing the job and in completing the learning process. And so, I think I will skip this. I think the last thing that I would like to share with all of you is that based on what we have done, in fact, what we have done is that our team has developed a kind of port and supply chain systems based on the port operations of a number of ports in the Greater Bay Area in China, especially because actually my university is located in southern China in the Greater Bay Area. And so I think before we actually try to use the so-called real ports and work on it, we are trying to build a simulation in our laboratories in trying to understand when we have established or applied this PortEdge system into it, how would it perform? I think a few things that we can look at. The first thing, as you can see in this diagram, is the so-called a quantitative analysis of convergence efficiency. Or put it very simple, how efficient can we actually use with the application of PortEdge, how efficient we can actually allow the job to be completed, to actually to complete the cycle of a learning process and make a transformation. And you don't need to look at the figures, but put it simple. Different lines have indicated what? Different lines have indicated that it has a different computational capacity and a different band length and also a different cycle frequency. Or put it simple, a weaker system and a stronger system. How well do they perform? How much can they actually complete the job? And so you can see that what is quite interesting, if you look at the beginning of around below 20%, you can actually see some diversity between a weak system and a relatively strong system. The learning is quite different, but in fact, as time goes by, when it arrives at around 30, 40%, you can actually see that no matter you are talking about a stronger system or a weaker system, it actually seems that the completion cycle doesn't make a lot of differences. And so this has provided some indication that the PortEdge, this system, has actually enabled a computing system with different type of technical efficiencies. They seem to be able to help them in building up the system on improving the port. And I think this is the same for this so-called the second diagram on the right, the training loss. What is the loss during the training? You can see some differences before, but as it goes on, the system itself have actually learned, especially through the AI system, they actually learn about it, and so they have gradually, they more or less, they come up, because of the learning, they have come up with, and let's say those with the stronger system, they actually convert together and was able to perform reasonably well and doesn't make a lot of difference with each other. And finally, that is the final two slides that I would like to share with you. So if you still remember, two of the things that we are talking about is about, first, is the function completion time. It is about, and this is about quantitative analysis of the average job processing speed. The green line is the use of green edge. And so for the others, the PortEdge, and the others are based on other quite well-established computer softwares that are being quite publicly available, like the RP, SWPK, HRPRA. You can actually see that, I think from our initial simulation, we found that the PortEdge, our system, was able to actually perform quite well, number one, in terms of the pre-iteration time, as well as the accumulative latency. Both of them will actually perform better than many of the well-established softwares that we have at the moment. And finally, in terms of the runtime energy cost, you can see that also the case, how to read those graphs are pretty much similar, of which the green line is also the one that we have developed. In terms of both the energy cost of job processing and also the energy cost of heat dissipation, we found that our system seems to be performing quite well. But so, as mentioned, this is also a system that a project that we are still ongoing. We are still working on it. And then there will also be quite a bit of, will be very much the next step. We'll be able to hopefully also learn from colleagues, especially also from the industry too, about how to improve it and what could be the major issues, etc. So I think that's all I would like to share with all of you. Just a last word, because I just want to take 10 seconds just to introduce a little bit about my university. My university is actually, in practice, is located in Zhuhai in southern China, and is actually the mainland China's campus of the Hong Kong Baptist University. And so it's a joint university, and we do have we hope that there will be an opportunity. If you are visiting Zhuhai, please let me know. I'll be more than happy to welcome you to our university, and hopefully we'll be able to come up with some type of collaboration and cooperation. So I think that's all from me. Thank you very much.
Well, thank you, Professor, for your timekeeping. You said 15 minutes, and it's over 15 minutes, so...
I'm sorry.
It's okay. I'm kidding. So thank you so much. And now I'll turn the microphone to Mr. Hans Burmeister. I have to tell you, you look very different from the picture I have.
I also wanted to have a small surprise for you. If you see me for the first time, that's how I look now. People who know me for a longer time know the other haircut for quite a while. That's the funny things. Things are changing. Yeah. First of all, welcome. I'm very happy to be here in Korea again and to give you an introduction into maritime autonomy and its impact on future ports. And maybe a few sentences that you just don't know my pictures. Who are we? Fraunhofer, we are actually located quite well because we are a little bit the in-between thing between academia and the industry. We are an applied research organization that is primarily bringing technical innovation from the universities into prototyping and practices. And I'm heading a department there for sea traffic and nautical solutions. So if I deal with ports, it's more on the water side of ports. Yeah? So the approaches, the berths, the maintenance, dredging areas, and all those kind of things. I personally don't deal so much with the port operation that much on the land side. I have other colleagues doing that at our house, but I will dig a little bit more into the water side and primarily on the ship side of life, which is also important to ports from time to time, as far as I know. How do we do these linked to the industry? Just a few words. We primarily work partly in public funded projects, but the speciality of Fraunhofer is that we are primarily a buy-in R&D department. At least within Europe, there are not so many maritime actors having own R&D departments themselves, so often they come to us. We do the development and the prototyping, and I will also show some of the results later on, so it's getting more funnier the longer the talk goes. Why do I speak about maritime autonomy? Maybe a few words about that. I have been to Korea quite a lot before Corona, because we also had a lot of autonomy projects here. And we basically do a lot of the technology stack development for that area. So we have a lot of software elements available for that. We did a lot of technical demonstrations in the past on container vessels, on tugs for remote control and autonomous operations, which is why we have approximately 12, 13 years of experience in that area. That is also more or less covering the whole area of maritime autonomy as it is has been started around 2012, 2013 by a German-Norwegian collaboration project, primarily in its latest form. I know that there has been some developments beforehand. But so much about the basic introductions. Let's look a little bit into maritime autonomy. And if you speak about maritime autonomy or unmanned vessels, I think it's important to distinguish three industrial areas, and we will dig a little bit into all of them today. You have two major categories on the ships, and that's the SOLAS and non-SOLAS vessels. So SOLAS is the classical Safety of Life at Seas Convention. Those are all the classical large cargo ships which we know all around there, which have AIS. They are falling under IMO regulations. And then you have these smaller vessels, yachting equipment, where there's also a lot of, let's say, surface vessels and drones around there. I think some of them can also be seen out there in the hall, if I've seen that correctly. And those two domains are very much emerging in the area of autonomous maritime systems. And in Europe, we specifically also have the inland waterway transport next to that. It's still ships, it's still floating, but the regulation is totally different, at least within Europe. I have to admit, I don't know exactly how much it is in Asia. And in all those three areas, there's a lot of development going towards more autonomy and towards more remote control. And maybe a bit into the motivation beforehand, and I will not do my personal motivation, but give you some results from a recent study we did in Europe, and that was along a variety of German and European industrial players. So we only did interviews with CEO and higher management level on the industrial side to investigate what are the expectations towards the emerging markets of autonomous vessels, and did also some workshops to classify that. So I'll just give some short notes, and there are some QR codes in the back if you want to download them. It's 100% in German, but I think they're great translation services, and there will also be a small summary next month in English. But as a first insight, I think one of the interesting things about autonomous maritime system, when I started with that around 10 years ago, you basically get kicked out of any conferences as soon as you spoke about unmanned or autonomous vessels. Fortunately, the first conference was on the ferry, so it was impossible to kick me out. So I'm still here. If you see what has changed in the last decade is that there's a very much more positive attitude towards that. So also if you look at the results, many players, and I have to admit, we don't just interview those who have autonomous systems, but we also interviewed a lot of the companies who are not actively positioned in that field at the moment, see that this is an emerging technology, that they are positive towards that, and that they are even aspiring to have an own active role or even market leadership in that domain. There's also a certain part, I think it was around 10% in our case, who doesn't want to be active at all in that area. But nevertheless, that was very, very positive results. And there's also a lot of activity going on within those companies. So over 50% do active research on those kind of systems themselves and want to position them there in the future. We also looked into the different branches and technology branches which we are having in maritime, and there's of course the supplier side, the shipping side, shipbuilding, but there was also one special focus on ports, and I think that's the one that is also more interesting here, and I will dig a little bit into that. We try to classify them based on the diffusion theory. That's basically a theory from economists showing you how far in technology innovation has already been adopted by the different players. And if you look at the different segments which we're having in maritime, of course, the supplier manufacturer side and the shipping side, they are very far off. So there, even early majorities are entering that market nowadays. And to a bit of surprise, to be honest, the next one was ports. If you would have asked me, I would have not expected them that early. But the funny thing about science is sometimes my own hypotheses are not true. So that's one of the actors that is also now getting more and more emerged and involved into those kind of systems. Why is that so? Because I think they see that there's a certain potential in those autonomous maritime systems, the more autonomous those get. And it differentiates a bit. There's, of course, the part where the ports themselves want to use those kind of systems, and I will show later on. And that's also the part where they expect to get new cargo volumes by autonomous vessels going into the into the markets. Regardless, if you looked around the ports, and I think it was 12, 13 ports involved in that questionnaire, nearly all of them agreed on the fact that they will have a significant raise of those autonomous maritime systems in the next decade by up to 40% share in total in that. Of course, they're also using and playing around with those kind of systems. Some are already using commercial products. That's very much in this hydrographic and dredging area. Others primarily work with prototypes and R&D domains. So that is there, specifically in the areas where they are using that. What they are looking into now is which kind of infrastructure adjustments they need to attract those cargo volumes in future as well. And one of the areas there is specifically the navigational support technology. So what kind of aids to navigation, electronic leading lights and stuff like that we are going to have in future. Docking systems is also one of the areas that has been discussed to bring to enable those traffics into their ports. But for today, I would like to look a little bit onto some impacts, and that's a little bit the research strategy. What you see here is what we cover at all at Fraunhofer, and I want to look a little bit into ASVs, remote control, as well as inland barges with 3 exemplary cases, how the future for ports could look like and what impacts are possible there. I could also speak 1 hour, but I was told I have 15 minutes as well, so I keep it small. One of the initial things, and that's more on the cargo side, which we are foreseeing that is happening at the moment very much specifically in Europe, is the emergence of smaller autonomous vessels concept specifically for the inland navigation. There are different actors out there, CFA with the remote control technologies, Zulu Associates, which are building vessels, and we are operating one project called Autoflex at the moment, and that is for changing the port hinterland traffic. So basically to increase the modal shift for feeder services on coastal and inland waterway links. Why is that so? If you do some economic studies, and those are available online as well, operating a fleet of smaller mass at higher frequency has quantifiable effects on the inventory management. And I would like to challenge a little bit also the discussion which we had in the morning. At least for these hinterland traffic, we are competing in the modal share with trucks and trains, which are by nature faster. So the difference maybe to deep sea cargo is that here time matters to a certain degree, and having a smaller fleet with higher frequencies, more direct port calls, because we don't need to go around as 50 feeder ports, has certain effects which makes it more attractive for logistics, and that is something that you want to address with these small and autonomous vessels, which you can't operate with the system that we have nowadays. So what we are currently looking at is what kind of key elements are needed to facilitate those modal shifts. And the idea is that it will be primarily a small barge. The idea of the small barge is that it can use all the old waterways which we are having in Europe, which you can't operate with modern inland waterway vessels any longer. Why can't you operate them? Well, basically, if you can just transport 30, 40 containers and you need to pay 2 persons on that vessel for not even 24 hours operation, that's not cost efficient. So the idea of many of those business concepts is to go for unmanned units which are centrally supervised. And even maybe with electric possibilities, because if you don't have the bridge any longer, you could use that space for battery containers. We have a project there going on funded by the European Union where we are looking into those concepts, where we have a barge involved and where we will also do testing of those equipment under real-life consideration, plus all these related case studies. What is the case study that we are looking at? It's primarily in the Netherlands and Belgium, like basically all inland waterway cases in Europe. Why is that so? Because they have very advantageous regulations for those kind of things compared to my own home country. But nevertheless, we are happy to do it there. And we are also very happy that we have DFDS involved. That might not be that much known here, but that's one of the major short sea logistics providers within Europe, also operating a lot of own vessels, which is providing the barges, which is interesting in that concept, and which enables us to really do live testing and demonstration, and hopefully also has a chance for the rollout at the end of the day. It's a 3-year project, so we have 2 years up to go. We are currently planning the first technical installations. We will take some of the technology from the maritime domain. We have maritime robotics involved. Some might know them. They do those equipment also already in the maritime domain for smaller ASVs and adapt that to the barge installation. And then we can hopefully show some videos here in future about that, and also finally have an effect on the modal split for more green port hinterland traffic. But that's not all. Another case where we see some changes coming up is in the area of pilotage. And what I mean specifically is remote pilotage. And first of all, let me clearly state, if there are pilots in the room, it's not about making pilotage obsolete. That's a very important task, and you need to have the expertise of the pilots to safely guide a master, to safely guide a ship into the port. But it's maybe a more modern and virtual mean to execute that task and to assist the onboard crew. Because what happens today is basically that you still go out with the pilot boats in 3, 4, 5 meters waves and then climb up a ladder in rain. And frankly speaking, that's not the safest way to board a vessel. I know that you can also do it with helicopters. That's nearly as unsafe as you do it in the other ways. So you have a lot of problems there. Many of those pilot boarding arrangements are not fulfilling the safety standards, and we also have casualties each year. I think within Europe it was 3 dead people last year. Also Singapore lost a pilot, if I remember correctly, and also some other first world nations. Given the fact that this is a very high professional skilled person and there are not so many out of the world, that's quite a high fatality rate, to be honest. So the idea is, how can we change that, and how can we make a pilot assist the vessel without maybe the need to really go out there and climb on board the vessel? Unfortunately, that's typically when they need the pilotage at the most. Second aspect is also a bit sustainability. If you think about helicopter transfers and these small pilot vessel transfers, they are also burning some fuel. So I think also we did some calculations for Denmark that's around comparable to 5,000–6,000 cars per year, just for such a small country. So there are also some effects to maybe get rid of that. And what we did there is basically a first trial exercise together with the Finnish university, and that's the Repoman project. I will show a bit the video in the background, which we have installed on the ferry between Germany and Finland. And the big issue for the pilot is how to get the situational awareness, and we are experimented with augmented and virtual reality in that case, where we did a camera stream. And you see then here the remote pilot, which is basically standing on shore and getting a live feed from the ship, including the camera plus all the navigational information he would normally have on board, into his system. So he sees the vessels, he can look around like in nature, he gets the information from radar and active screens, and he can even interact with the chart. That's a very early prototype, but the funny thing is, if he sets markers here, and if he makes adjustments there, those are then also forward to the vessel, which looks like that. So we have our captain here, which has then augmented reality glasses, and basically gets the information from the pilot into his field of view. So he can turn that on during that services. He gets highlights of certain areas, which are of importance, and of course they also have some voice communication between the two of them going on. So it's more or less a human-centric interaction, which they are going to have, despite the fact that they are not in the same room. Of course, that looks very nice, and that has been tested now by a couple of first prototypes, together with German, but also together with the Finnish colleagues, which are very much leading in the area of remote pilotage, and which we are now looking to do further development and trials in future to get those kind of systems as a real assistance to existing vessels. You can then, of course, also put in further situational awareness systems for highlighting certain objects to further enhance that. Why do we go for those kind of mixed reality things? Well, if you want to go remote, you will lose certain senses. Yeah, I know if pilots go on board, they also use hearing, you feel how the vessel is moving, all those kind of things. You will not be capable to transfer that. Yes, there are technical possibilities to do so, but it's not really worth the effort. 70% of the perception of the human is normally done by the eye. So we need to get that captured as good as possible, which is why we use on those camera streams. And then we can further enhance that within the field of view to make that perfect. So we think those kind of technology is helpful to have an effect on remote pilotage, also compared to the screen-based systems, and has certain effects as it could enable those worker safety of pilots issues in the future, and which is why we are believing in those kind of technology and try to push that forward a bit. And that is, of course, also how certain things might change in future, despite the fact that it's very nice to see pilot boats, and I have recognized 3 of them in front of my hotel this morning. The last thing that I would like to look at is then port services, and that's maybe one thing where we see more and more those kind of small units operating in ports for certain areas. We once came up with a certain idea which we have called RoboVAS, so robotic vessels for port services or vessels as a services. And the idea was there to use small ASVs in port for certain operations. Hydrographic survey is something that you need to do. We're experimenting with dredging tasks, which is primarily important in Europe, but also surveillance tasks in the future, where you can use existing vessels next to all the vessels which you're already operating in the ports and get them further. That was an initial project which we did together with the Port of Hamburg, for example. The Port of Hamburg is now also having some of those autonomous vessels in their fleet for hydrographic services to get that forward, and where you also have better accessibility to certain areas. And the other thing that is coming up where those kind of things are also used, I guess we can limit the music a bit, is of course for surveillance of maritime infrastructures. So we are looking how you can use that for continuous operation. You might know that this is becoming a more and more serious issue, also in Europe, also in the Baltic states. It's barely possible to monitor such a large area just by humans at the moment, and we also don't have the cost and capacity for that. So we do trials at the moment how a fleet of those kind of vessels can safely guard a certain area for the sea or in the port. So what you see here is some swarm operation between those ASVs where they do inspections of certain vessels, so they pass by, do certain scanning, and can autonomously interact in a certain area. But besides the pure inspection task, there will also come an intruder at some point in time, which is then detected, and where you then can go and try some assistance. I know if you know US Navy fields, there are also other things how you could do that, but in that case it was primarily about detecting and then diverting a certain phase to protect critical infrastructures like port areas, harbor entrances, also other areas. So here you see the Invader, these black motorboat at the end of the day, and the rest is then autonomously acting there, going there, trying to intercept with that vessel and maybe detect it to the side or safely guard it to coastal or coast guard or police stations in a certain way. Non-interference, but of course trying to get that thing. And those are cases which are coming up where ASVs will presumably have a certain change on how we see those kind of things today. Those tests have been carried out in Kiel last year, and we are currently further developing that also for other occasions. So, as a short summary, because I think I might have way more introductions otherwise. What are recommendations? Within the big study, we did one specific recommendations for ports, and that was basically that you need to actively position yourself as a port for those autonomous maritime services in the future. Frankly speaking, many ports are speaking about that, but none has really pointed out to lead the way there. They're using those technologies for their own services, but not for cargo attraction yet. And I think what we will see in Europe is that at some point in time, one port will go ahead there and then presumably also set the standards. At the moment, everybody is waiting for somebody to do the standards, and then if somebody else is doing that, they're also not happy. So we will see how this is going to change. But I think that's something that specifically for these feeder services within Europe will have a certain effect at the end of the day. Because what is the big challenge with autonomous maritime systems still so far? There's a lot of uncertainty on regulatory domains primarily, and with those kind of large-scale testbeds and trials, we hope to reduce that, to have a quicker adoption, because there are definitely gains and safety and commercial wins for those kind of systems in the future. And with these words, I promised some QR codes if you want to download that, or you can reach me on LinkedIn, and I'm looking forward to the further discussion. 고맙습니다.
Well, I think I made a mistake. I think I should have dedicated 1 hour for you. No.
Next year.
Okay, now can I turn the microphone to you, Mr. Im Do-hyeong, the CEO of Abacus?
반갑습니다. 아비커스 임도영.
Good afternoon, I'm Im Do-hyeong from Abacus. I wanted to deliver my presentation in Korean, but the organizer asked me to deliver my presentation in English.
Everyone, I am Do-hyeong Lim, CEO of Abacus, subsidiary of HD Hyundai Heavy Industry Group. We are focusing on autonomous navigation solution. Today, I will talk about the commercialization status of autonomous ship technology. Before discussing autonomous ships, let me first talk about autonomous car. The image on the left shows the level of autonomy as defined by SAE, Society of Automotive Engineers. Level 1 and Level 2 autonomy refer to the system where detection, decision, and control are performed by the system, but human driver is still responsible for the controlling it. This is commonly known as the ADAS, Advanced Driver Assistance System. ADAS first appeared in early 2000 and has since proven its value in terms of safety and convenience, becoming a standard feature in most new vehicles today. In history of autonomous vehicle, some companies aimed to commercialize the higher levels of autonomy from the start, like Waymo, while others focusing on commercializing low level first, gradually increasing the level of autonomy. A prominent example of the latter approach is Tesla. Tesla has simultaneously achieved both commercialization and technical advancement, and then enhancing the company's overall value. However, even Tesla has not yet reached the level 3 autonomy. From the perspective of technical maturity and product reliability, it seems that the commercialization of level 3 autonomy will still take time. This is our insight from the automotive industry. First, with the advancement in AI and sensor technology, autonomous systems in automotive sector have been successfully validated and are expected to rapidly expand into other areas such as shipping, robotics, and UAM, etc. While it took 20 years for autonomous vehicles to reach commercialization, autonomous ships are expected to achieve commercialization in much shorter time frame. 3. However, the commercialization of level 3 or higher autonomous system will take more time. 4. Even after autonomous ships are commercialized, for the next 20 years, the majority of vessels still rely on the level 2 or lower navigation assistance system, with the human operators remain on board. This is IRR's expectation. By 2025, there will be a global shortage of around 150,000 seafarers, making ship automation and autonomy increasingly important. With over 80% of maritime accidents caused by human error, autonomous ships can reduce this incident. Additionally, optimal autonomous navigation is expected to save fuel and significantly lower carbon emissions, making autonomous ship operations an inevitable megatrend. As a result, various companies around the world are actively developing autonomous ship solutions. Some companies have commercialized solutions focused solely on situational awareness, while others have introduced products that integrated both situational awareness and control functions. However, compared to autonomous technology in the automotive industry, the commercialization of autonomous ship is still at a very early stage. Autonomous ship technology, like autonomous vehicles, rely on detection, decision, and situational awareness control systems. However, a different approach is required to address the unique challenges of maritime environment. Ships have a large inertia and no brake system, which creates challenges in situational awareness, as they must detect a small object using the computer vision. And unlike a car, ships have no designated lanes, making decisions more complex. Additionally, control is difficult due to the sensitivity to external forces like wind, wave, and current. To address these challenges, it is essential to develop technologies specifically tailored to the maritime environment. We are actively using the generative AI to create diverse data set relevant to maritime conditions. And we are also working on finding the optimal sensor combination for specialized for maritime use. And additionally, we are exploring the use of reinforcement learning to achieve auto-docking control like a human. Abacus was a spin-off from the HD Hyundai, the world's leading shipbuilding company. In 2021. Abacus autonomous navigation solutions are now being installed as a standard feature on all HD Hyundai ships. To date, we have received 600 orders, more than 600 orders, and our systems have been installed on more than 100 vessels. Since its establishment, Abacus successfully conducted a series of demonstrations. First, we carried out autonomous canal cruise tour in 2021 in Pohang Canal, South Korea. And in 2022, we carried out world first Trans-Pacific crossing with autonomous technology for LNG carrier. In 2022, also, we carried out world first autonomous leisure boat demonstration in Miami Beach. Route optimization and route tracking, adaptive cruise control and collision avoidance, and auto-docking we carried out. And last year, we demonstrated the electric-powered autonomous boat near the Haeundae. Abicus is leading the way in autonomous navigation technology through these milestones. As I mentioned, we are focusing on level 2 solution. It's a human driver. Machine driver, but human has a responsibility. We have two solutions. One is HiNAS for commercial ship, and second is a U-boat for leisure boat. Today I will mainly talk about HiNAS. HiNAS is an all-in-one solution to enhance the safety and efficiency. As a level 2 autonomous system, it supports a pilot, but the pilot has a responsibility for the navigation. It features a 360-degree surround view system for safe docking and undocking, a situational awareness system for navigation, and includes optimal route navigation and collision avoidance functionalities. HiNAS has been certified by each classification society and flag state. In particular, it is undergoing the world's first type approval in accordance with the DMV's revised autonomous guideline, and is carried out, is scheduled to be completed by end of this year. We had an event in Hamburg 2 weeks ago to commemorate this. The core function of HiNAS is a vision-based situational awareness. Based on 6 cameras, it can automatically detect the object based on deep learning, even during the day and limited visibility condition, night, heavy cloud, heavy fog. It also improves the performance by blending EO and IR cameras. Each sensor has its strengths and weakness, which is why we use sensor fusion technology to integrate AIS EO-IR camera and X-band, S-band radars. This enables a comprehensive situational awareness. And this video you are watching demonstrates the results of this sensor fusion technology. HiNAS SVM uses a 6 to 10 fisheye camera installed around the ship to provide a real-time 360-degree top view. This system allows operator to see the distance between the ship and surrounding object, helping to prevent collision and collisions. The ability to automatically infer ships from the 306 degrees SVM has also been added, and it is also possible to monitor other ships in a wide range via AIS signal. The video recording function can be used for insurance and crew training. Lastly, HiNAS control interface with the existing navigation equipment, including autopilot and BMS, bridge management system, to control the course and speed. Through optimal route planning and execution, this system helps reduce the fuel consumption. This is the route planning and autonomous navigation. And collision avoidance technology is required in various encounter situations. We have improved the collision avoidance algorithm through tens of thousands of cases of testing for DMV type approval. This is some example. Let me share a case study involving the application of HiNAS. We installed HiNAS on 325,000 VLOC O carrier operating between Brazil and China and compare the result of autonomous navigation with the traditional human-operated navigation. Over the course of the months-long voyage, the ship was able to sail with a minimum human intervention, requiring only daily one operating to update weather condition. Feedback from the navigators highlighted that HINAS ensures the safety and convenience while reliably maintaining the ETA. Now let's move on the topic of fuel saving. Through comparison of test result, it was confirmed that HINAS has a fuel saving effect of 5 to 25%, depending on the operating conditions, compared to the existing human navigation method when applying the method based on measurement data normalized by operating speed and simulation-based method. 5% fuel saving means annual reduction of $800,000 in fuel cost for large container ship. Additionally, it would result in a yearly carbon tax index of approximately 100,000 euro under the EU ETS. In addition, achieving a 5% fuel saving can extend the operational lifespan of ships that would otherwise be non-compliant under the IMO CII, Carbon Intensity Indicator regulations, by 2 to 3 years. Autonomous solutions are currently the most CapEx, OpEx competitive solution in the market, compared to other eco-friendly solutions such as air lubrication and rotor-sail. Even with a low-level autonomy, HINAS has already proven its significant value in terms of safety, convenience, and efficiency. As the level of autonomy increases, the customer value of autonomous ship technology will grow even further. This technology will fundamentally transform the future of maritime industries. Thank you for your attention.
네, 좋은 발표 감사드립니다. And finally, it is now your turn. Thank you for waiting. Now I would like to ask Seouri, Senior Terminal Process Manager from LBCT.
Good afternoon. My name is Seouri Koo Sung, and I am the Senior Terminal Process Manager at Long Beach Container Terminal. Right now I work in the Operations Development team, and I was fortunate enough to start my career before Pier E go live, and I've been able to see the transition from our legacy terminal to our automated terminal now. So I guess the previous presenters talked about research and test cases, and I guess I am the example of an applicable, in-use, successful automated terminal that is going on as an industry leader. Okay, so Middle Harbor Redevelopment Project is LBCT PRE is the final product of combining two aging terminals into a state-of-the-art facility that has been named one of the world's most technologically advanced and greenest facilities in the world. This new facility in the Port of Long Beach, the idea started in 2007 and construction started in 2011. So right now, we had our first commercial vessel, the Costco America, in April of 2016. So this idea, transitioning from the old to new, we started working on this idea hand in hand with the ILWU, which is the International Longshore and Warehouse Union. And we wanted to turn this idea into reality. And how we went about doing this is we invested in our people. We invested over $9 million in training before we did the actual go live. And we started with classroom training for our steady ILWU operators and employees, and we helped them transition from the old to the new systems. We have continued to stay committed to the 100% preservation of the union's jurisdiction for all new and modified jobs, and we have included now a force of over 130 highly skilled ILWU mechanics. So one of the best parts of talking about our terminal is our terminal cross-section. I love how we put our design into it. You'll see from left to right. On the left side, the vessel operations where the ships dock, they come in. We have an operator in the crane. And from there, you have a transport area where there are UTRs, utility tractors, and manned vehicles going under the cranes. Then you'll see, actually that's vessel operations. And then from transport to storage yard in the middle section, it's fully unmanned. So we have a fence control systems that we make sure that no one goes in there. And this is a very big safety part for us. We have separated the manned and unmanned areas to reduce the amount of accidents and make sure that we improve on our safety procedures so that we can preserve how we continue our operations day to day. So this is just some of our terminal particulars. I'm not going to really go into it. You can take a picture, but this is what we have. We are now fully built. We went from phase 1, phase 2, phase 3, and we did it in phases. In phase 1, we went live with 1 berth. And in phase 2, our legacy terminal shut down, and the Pier E started with 2 berths, and now we have 3 berths, which means we can have 3 vessels alongside, and we're able to provide good productivity throughout those. So our operating systems, we use Navis N4, now Caleris owns, and also Teams, our ECS is Kony ECS, our equipment control system, and our crane management system is ABB. So this is, all 3 systems have to be in collaboration and work well for our terminal to be functioning. And there are various other systems that have to come into play for our whole terminal to work together. So just a little brag about LBCT and how we've done. So in 2021, when we went through the pandemic, LBCT has had no vessels forced to anchor. Our high productivity has allowed vessels to work and finish much faster because of our automation. We have been able to keep the skilled labor, we have been insulated from the skilled labor shortages that we had at the in the Port of Long Beach and LA. And over the last 2 years, LBCT has worked 37 ad hoc vehicles that were stranded at anchor. LBCT, we have done our part to clear out the vessel backlog that we saw during the pandemic. So this is our berth productivity. This is the Ocean Alliance data that has been provided. The part is us and everyone else. I blacked out who the people are, so just want to talk about LBCT. So this is our 2024 year-to-date average turn times. On the left side is our turn time average, is 48 minutes, and everyone else in the Port of Long Beach and LA terminals. And for our intermodal performance, LBCT is the largest on-dock facility in North America, and we are currently the fastest and most reliable on-dock rail. This data is from 2021 during the height of COVID, and you can see that during one of the busiest and most congested times in our industry, we were able to have more IPI containers and lowest average dwell in the harbor. So I think LBCT is an example and showing how automation can do its part in collaboration with our union to be able to have a successful container terminal operating now. Thank you.
That was fast. Okay, we actually don't have a lot of time left, but Now it's time for the Q&A session. So I'll really turn my microphone over to you, Professor. I'm sorry about the time pressure.
No, I think it turns out that time is pretty okay. Right? So thank you. I think we do have time for a couple of questions. I think probably what I would do is, in fact, I actually received 2 questions. From sending it to my phone, and maybe the first question is that. So I think first what is saying is great presentation, and but then a lot of things has been talking about the technical side, about automation, about AI, about how things will be done. However, it seems that the process, like the inputs from the frontline workers, doesn't seem to be well addressed. And so, while not always not necessarily the only reason, but I think in the latest, expected ILA's strike, probably it at least partly illustrated that I think there are still a section of the people that the frontline workers might still be suspicious about. Automation in ports and also in the supply chain. So I think the question is, the question to the speakers was that, so how to actually enhance the communication to frontline workers about the advantages of automation, and has something already been done on how to improve that and to change the perception? Thank you.
So I think that's a very good question for me to answer, because we went through that hand in hand with the union. On the West Coast, it's the ILWU. And when this idea was introduced by Port Long Beach for the Middle Harbor Redevelopment Project, they were not happy. We got a lot of issues of jobs are going to be taken away, and we're not going to be able to keep what we need to do. But what our company CEO, Mr. Anthony Otto, has been able to do was work hand in hand with our labor union and have transparency. We were able to show them what they're going to be using, and I actually took part in training our labor personnel. And in the beginning, it was very difficult. A lot of people did not want to use computers. They didn't want to use it in a new way of doing things. Like, I don't think anybody likes change. So it was more a lot of hand-holding. It was a lot of assuring that we're not taking away jobs, but more so we're going to be putting more jobs with skilled labor. And we were able to work very closely, and I believe very successfully, because we've been known as a very labor-friendly terminal, because up till now there was not that many. Anytime there was a new issue, we were very transparent. We introduced what we were going to be doing, and it was more of a cooperation and hand-holding than anything else.
Yeah, if I can maybe add, I'm not so much working on the terminal side, but of course on the ship side, ship bridges, there are typically similar concerns. What we made a lot of positive experiences with is with these kind of living test labs. Yeah, so we do a lot of our demonstrations in live cases on board of the vessels, so that you can get ambassadors trying out those technologies. And one of the main learnings there, which I see, is in the maritime navigation domain, you every time have this factor of human-centered design, which you also have in nuclear industries, but not in so many others. I think many of the new technologies are not necessarily failing because the principal idea is bad, but the interaction is really horrible in many cases. Yeah, I know that there's this nice example, my search engine, and you see the Google line, and then there's my ERP system, and that's 50,000 drop-down menus, which are designed in an Excel sheet from the 90s. And that's also how many of the new technologies are introduced by developers with all their back-end technologies, but not with a good user interface. And I think the time for those kind of automation, at least I would say within Europe and also within the classical industrial nation, is actually good, because we have demographic shift and changes. So specifically in these traditional dirty, dull, and dangerous jobs like we have in ports, but also on ships, on offshore platforms, on oil platforms, there is a lack of people coming afterwards. So you need to find new solutions how to operate those kind of things. So also frontline workers which are currently underway see that there's a change, that nobody is coming afterwards, but you need to do it in a proper way. So going into these live test beds and experiences with them is something that's really helping, and I think then you also get positive results, even though we also need to acknowledge you will not be capable to convince everybody.
Sorry, I will speak in Korean.
So, adding on to that, so, according to carriers which have adopted our solution, so according to their CEOs, it's only 5 years ago, people resisted the idea of autonomous operation and autonomous vessel because they were afraid of losing their jobs. But since the Gen Zs do not want to be on board, well, for example, from Brazil to China, for 1.5 years, there was no human intervention whatsoever other than the weather update on a daily basis. Well, it was so convenient to all the seafarers. So they believe that this will work for the welfare and the benefit of the seafarers. For example, if there is a vessel incorporating ADAS, and if there is another vessel which does not incorporate ADAS, well, the presence and the absence of the solution like ADAS, well, this will definitely reduce or increase the workload of the seafarers. So this would also help them attract the talent and the seafarers. That was one of the feedbacks we have received.
Thank you. And well, probably I think I am really the one to be suitable to chair, and because I think that actually the responses actually gives a very follow-up to the next question. Because so I think what we can see, one thing for sure is that I think automation, it actually means the need for a new set of skills, and so clearly I think in many places, many universities, institutions around the world, and also including institutions and universities in Busan and in Korea. So there are a lot of these like maritime programs. So I think especially from your industrial point of view, in phase with automation, in your opinion, what will be the type of, for example, new courses, new contents, or new skill set that should be included in this program, so that the graduates and when they are getting into the industry, when they're getting into the work, will become more competitive, efficient, and perhaps also more aware to ESG. Thank you.
Yeah, I think, I mean, first of all, I think we have to acknowledge that presumably you will not get people out of the university and then they will be capable to do a job for 40 years, yeah, because things are changing in between. What we have seen in the navigation domain is that, of course, that some of the nautical schools have positioned themselves very early with offering, let's say, autonomous navigation expertise and master courses and stuff like that. And frankly speaking, to 80–90%, that was the same study that they've done before, and then a little bit more on digitalization skills. But that helped to attract a lot of people towards that universities. And also, if you look within Europe, where now the clusters of the industry in Norway and Finland are, for example, that also helped to establish the industries on the technology side in those kind of places and not in other places. I think specifically in maritime, we have to take into account that maritime education is internationally regulated by STCW, so the Standards for Training and Watchkeeping and Certification, which is a minimum standard that many people tend to forget, but maybe that needs to be revised, and I know IMO is of course going on in certain cases to put more digital competences in that. Yeah, I mean, frankly speaking, we're also not teaching the sextant any longer. I think it was not that long ago that that was still part of the mandatory education, and given the fact how satellite systems work nowadays with Russia, maybe it's helpful to regain that skill again. But nevertheless, I think there needs to be an update also on those kind of international convention on the minimum standards to go more into digitalization. At least on ships, people will more get into the monitoring mode than in an acting mode, but they need to have the thorough understanding of the IT systems to use that and to be that.
On our side, on the terminal side, I think, especially in the West Coast, I'm not sure if a lot of people know the maritime industry. I grew up in California, and I didn't really know until I entered. So I think there needs to be a lot of good like marketing and, hey, this is a whole different industry, because it's a very niche industry. And I think the Port of Long Beach actually does a really good job of getting high school students and doing, we have luncheons and stuff that they, Port of Long Beach and Port of LA, they're able to do. And I think we need to do more of that and introduce our industry to the younger generations, because I don't think I would have ever really known about it if someone didn't introduce it to me. And so for me to see a lot of college students here, it's actually so interesting to me, because we wouldn't have seen it where I grew up.
Well, I'm not sure whether I fully understood the question, but I'd like to touch upon two different aspects. The first is about development. When it comes to the development of autonomous ship and autonomous vessels, autonomous user experience is the skill set required. And we also naval architect. We also need a naval architect for the development of the solution. And we also need an engineer who knows in the vision sensing with the electronic engineering major. And I also need a computer scientist. Now, all these skill sets and expertise should come together in great harmony to develop an autonomous vessels, but whether users are required to know all of this, that's not the case. We use iPad intuitively, so users should have a very user-friendly and easy-to-use experience in using a new system. But since the system is introducing into the industry, we need a minimum level of user training. That's my understanding. So in providing a solution, whether it's a user simulator and those tools, this kind of tools is provided along with the solution. That's the approach we take for the users.
Okay, thank you. I think maybe we can have just accept maybe one question from the floor. May I ask, like, are there any questions from the floor? I think that's one over there, right? Yeah. So can you please
raise your arm again?
Yeah.
여기 하늘색 옷 입으신 분이에요. 네.
May you please also introduce your name and your affiliation?
네,
Thank you.
안녕하세요. 저는 동원로엑스의
I'm Kim Byung-chan from Dongwon Lorex. I'm Kim Byung-chan from Dongwon Lorex. Thank you very much for such an insightful presentation and discussion. Automation is well on the way, whether it's for ports or ships. As for ships, the level of autonomy is relatively low, but as for ports, in the case of LBCT, compared to other ports, has high productivity and efficiency thanks to automation. The current level of technology available but I think, well, in the past, the technology was kind of nascent. So we have seen the progress of technology and the development of technology itself. So over the course of developing the technology to the level it is, I'd like to know whether there were any difficulties in upgrading the technology as you introduced this concept of automation into the actual field. So at the time of introducing this technology and automation, it must be quite difficult and bumpy. And now it is smooth. So were there any difficulties so far?
So I didn't put that in because I think I kind of understood. The hardships of implementing automation right? Was that right?
Yes, you're right.
People. Hardship was personnel, getting the training done. Whether it was the crane operators who were operating new cranes, because the new automated cranes are completely different from the standard cranes, or the clerks who were doing the planning, the vessel planning, or the TOS, the terminal operating systems. It's a whole new system for every single person involved. So training was the hardest part, and getting people on board and really to let the system do its job was really hard. And as one of the trainers, as someone that was part of training, the manual process to break that cycle was probably the hardest part of getting over the initial hump of implementing automation into our operations. And we still have those, but because we have a steady employee with the labor right now, I've been at the company for 9 years, and so these folks have also been at the company for upwards of 9 years, so now they're used to it. And now we are now a terminal where other labor personnel want to come to our terminal because it's easy. You just click a button, it's easy, you let it go. But it took us a long time to get to where we are.
Please.
Yeah, I think the big challenge with those kind of things is once you transfer from the developer interacting with the system to the user interacting with the system is to gain the trust into that system. The developers typically still have the chance to understand how the system works. The user normally don't. Yeah, not in general, I would say, at least, just on a high level. And what you fear, or what you have to acknowledge, that in all cases where you're doing it, being it on the terminal, on the ship, or in any other kind of industry, that there's a certain transition period. Because the users which are now need to interact with the new systems, they don't have that experience, and that doesn't really help if somebody from the developer or class society or somebody else tells them that it's safe. That needs some own experience by those persons, and typically you have something like that in the beginning, that it's like if you have a new dog, yeah, you put it on the line for 2.5 years, even though it's not running away, because you still need to have the trust that it's really not running away. That's something that's really hard to overcome with training, that needs a lot of communication, but that also needs that transition phase where people can test that accordingly. And I think that's one of the big risks with all new technologies, that if you have a failure in those early phases, it's overshading all the benefits that you can possibly have. And I think the big challenge with automation is most people change certainly from acting to monitoring. And what you have to take into account, that if you monitor something, that the system might act differently than you. And I don't mean in general, or if it's safe or unsafe, but they might, for example, act later. And also most people who at some point in time became a manager of other persons find out that their employees do certain things differently that you would normally do. And you need to have more thresholds into the people's mind in that kind of things, but that requires time. And I think that's something that we will not be capable to change that far. Therefore, it's important to take that into account once you introduce those new kind of technologies.
네, 대표이사님 쳐다보고 계신데.
Mr. Lim.
I think probably then, maybe if there are no further questions, I think we are a little bit overrun. But,
yes, you are.
Well, but I want to emphasize we start a few minutes late too.
Yes, you're right.
Okay, so I think if that's the case, then I think we can close the session, and maybe I can give you the stage back.
Okay, so I have just 3 words to wrap up this session. So cheers to chaos. And by the way, this is water, don't get me wrong. So why don't we give a big round of applause to our panelists and speaker and moderator. Well, thank you. And now it's time for a coffee break that you've been waiting for. So we'll have coffee break until 4 o'clock. So please enjoy the snack and beverage outside. Feel free to go down. I'm sorry. Okay, so we'll resume at 4 o'clock. 네, 안내 말씀드리겠습니다. 잠시 후에 저희 4시부터 세션 3 시작하도록 하겠습니다. 그동안 저희 커피 브레이크